Hey guys, welcome to DevOpsSchool. In this video tutorial, we are going to learn about Docker. It helps us to create, deploy and run applications by using containers. After going through this tutorial, I promise you that the concept and understanding of the Docker will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOpsSchool certification level courses which will help you to emerge skills for a wide range of entry-level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai and in Pune. Simply compare our many courses, find the one that suits your style and schedule best and start today.
So during the discussion, I said in each operating system what mount get initialized, whereas only one mount is allowed. So what exactly the meaning of it? Empty mount namespace. So guys, mount is equal to file systems. Understand that? System. I said system. Now what is the definition of file system? You know that, right? File system is a collection of direct file inside a directory and subdirectory. That's called file system. Guys, there are various kind of file systems which we have. One is a boot file system. And there's some noise coming from Kalyan. Can you please move closer? Yeah. So there is a boot file system. Okay. There is a root file system. There is a user file system. And there is an app file system. Different kind of file system. Now boot file system, when I say, is basically kernel. Okay, kernel file system. Can you see from your eyes during the runtime? No. Not if it is not running, then you can check that file system loaded in the kernel. Okay, loaded in the memory. So here, boot file system. Let me see if I can get some idea here. Boot file system. Okay, and this image, look at this. So here you can read more about the boot file system. Okay, during the runtime you cannot sorry, you can see typically it's a kernel. Now guys, root file system, what is this? Root file system, the one which you can see. Let me show you root file system. See, have you seen this root file system? This file system, have you seen this? Have you seen this? Everyone? See, everyone has seen this file system, root file system. C drive is a root file system. D drive is a root file system. OPT, SBIN. See, this is a root file system in Windows. See. Okay. So guys, this is a root file system. So are you comfortable? What is a root file system? Okay. Everyone? Okay. Now, what is a user file system? Guys, user file system is what? Okay. This is, by the way, root file system mounted at the root. Okay. User file system is basically, let me show you. This is the one user file system, user-like file system. Let's go. Let me show you my user file system. Go to the C drive. Users Rajesh Kumar. Whatever you see here, it's a my file system. Any other user cannot see it because it's a my file system, user file system, user home. Okay, it's my user home, user file system you see here. Now, last one which I want to show you, the application files. Application file system means typically I install all of my software in the C tools. So this is the application file system of Maven. This is the application file system of Selenium. This is the application file system for Terraform, like this. Okay. So app home is your application file system. Every app you install, you set app home, right? So you application home, that's called application. So guys, when I say mount means what happens? Operating system is exclusive of everything. Okay, exclusive of everything. When you get operating system, you get a kernel file system, root file system, which you can see it, user file system, and some application file system. When I say some application, it not to be Apache all the time. It can be ls is one application also. Cat is also an application. Any command you run like a ps is also an application. It's there in the bin directory. So guys, are you comfortable with the mount concept now? Mount concept? Okay, great. So now the last question which I was trying to answer is, what is container? What is container? And before that, I gave you that what is the problem in the virtualization software. In the virtualization, what we have a problem with, see, virtualization technologies are good. It's good. But the problem here in the data center, in order to run 3 apps, I need to run 4 operating systems. And also hypervisor is a very heavy weight which consumes CPU, RAM and stuff like that. So can we do one thing? Can we do like this? Think about it. One more thing, guys, I'm again repeating one topic. In one operating system, how many network, PED and MNT you get it? 111. User multiple. Think about it. In one operating system, network, PED, MNT you get 111, user multiple. Okay. So now, can we do something like this? See here. Look at it very carefully. I'm proposing this architecture for time being. This is your hardware layer. Okay. This is your hardware layer. On top of that, there is only one operating system. Guys, when I say operating system, please understand, operating system has kernel. Kernel has namespaces, capabilities libraries, C groups. Each and every functions of these I have explained it to you. Now, on top of that, can we create a user? Let me create one user. 1, 2 user, 3 user. Can I run Apache here? Now, can I run Apache here? Can I run Apache here? 3 Apache. You know, you can run Apache. You can run Apache. Think about it. You can run Apache here. This is 80 port. PID is 50. And you are writing this Apache in OPT Apache file system. Okay. Now, can you run Apache? Second Apache, why in the second user also can run Apache on 80 port? Tell me, yes or no? Guys, yes or no? Yes. So other user in the same operating system, can he run Apache on 80 port? No, correct. Yes. No. No, right? How can you say yes? No, right? Because remember, in one operating system, you have only one network you got initialized. Think about it. Only one network you got initialized. And this network is being used by all the users. Shared network. So you cannot run. Now, can we have a PID 50? Tell me, PID 50 is possible for the other Apache also in the same operating system? No, yes. Because PID is only one initialize. I told you, look at this here, initialize 1111, where is the allowed multiple. And last one is MNT. Can we have O Apache, if this write in O Apache and this also write in O Apache, the data integrity problem will be there, right? Data integrity. So yes, you cannot run 80 port, 50 PID, O Apache, it's not good. But guys, what I'm doing right now, can I change the port number 80 to 81? Then I can run, other user can run. 50 to 51 PID automatically it can run. Instead of OPT Apache, here you see OPT Apache 1. Data integrity problem will not be there. Now, is that possible? Yes. You are going good. Now the question is, guys, if I run 1 user, 2 user, 3 user, change the port number, run multiple Apache, I can run it. See how many operating system you needed? Only one. You are saving it. Think about it. You are saving the CPU, RAM. See, in the virtualization model, see, you look at this. This is the virtualization model. 3 app, you need a 4 operating system. 4 operating, but here I need to run 3 app. I need only 1 operating system and no hypervisor, guys. No hypervisor. Hypervisor consumes lots of CPU, RAM and licensing cost. Operating system also consumes licensing cost. So lots of saving is there. But there is a problem here. There is a problem here. The problem is this username will be different. Directory will be different. And one more thing, load balancer. Ultimately, guys, in a data center, why do we run Apache? Multiple applications. So we can access through load balancer. End user, right? So end user will hit the load balancer. Tell me one thing. Load balancer can load balance this Apache and this Apache. Tell me one thing. Load balancer, can he load balance this Apache and this Apache also? Is it possible? Yes or no? Tell me, guys, are you there? No, correct? Guys, it cannot load balance. It cannot load balance both Apache. Think, for load balancer to work, you need different IP address. Again, look at, hear my word, keywords properly, lines. Load balancer to work, you need a different IP address and the same port. Whereas in this, you have a single IP address, different port. Load balancer will not work. Guys, if both Apache cannot be load balanced by the load balancer, then we cannot serve to the end user. Then what is the purpose of running this Apache? There is no use of it. It's become a waste. But, can we do this? Can we do this? Think about it. Look at this here. Users, multiple are allowed. Here network by operating system, only 1 allowed. 1 initialized, 1 allowed by operating system. But actually, can we initialize the network at the user level? Think. Can we initialize the network at the user level? That means that user will get their own network, own mount, and one speed. See here. Think about it. Own network, own mount, own speed. Think about it. Now, I'm again repeating. This user is not accessing these resources anymore. Let me change the color. This user is not accessing these resources anymore. Shared network, share mount, share PMAP, which is created by operating system. This network is coming from a kernel, mount is coming from kernel, PMAP is coming from kernel. Now you tell me, if I follow this one, each user will have their own network and slice, each user will have their own mount, each user will have their own PMAP. Now, is there any possibility like we can run 80 port, 50 PID, OPT Apache? Is there any possibility? See here, this network PMAP mounts is not being added. Is there any possibility? Yes. Yes, it is possible. So what happens if each user, think simple guys, if each user will not access the shared one, each user will get own network, own mount, own PMAP, own network, own mount, own PMAP, own network, own mount, own PMAP. That way, it can run on 80 port, 50 PID, OPT Apache. 80 port, 50 PID, OPT Apache. 80 port, 50 PID, OPT Apache. And now load balancer will work because same port, different IP address each user will have. Each user will have a different user IP address. But there is a problem. This architecture will work. This architecture will work. But the problem here is Microsoft and Linux. These organizations say no, we would not allow to initialize MNT, PMAP, PID, and what network to each user. The question is, they were not allowing. Why? They said the reason for this is why? Reason is PC. What is the reason? PC. What is the PC stand for? PC stand for? Anyone? Funny question. What is the PC stand for? Yeah, guys, personal computing. Computer. Guys, for what? Human. You know that PC means human. Microsoft said, Linux said, I design operating system. For what? PC. OS for PC. Think about it. OS for PC. For human beings, not for data center. You are using to run application in a data center, that's okay. But we will not allow you to, we will not do that. Creating each user MNT, PID and network, we will not do that. We will allow only one MNT, one PID, one network to all users. That is the problem. Why? Because of PC concept. So they were right. Microsoft is right. Linux is also right. But these resources were there in the kernel all the time, but they did not use it. Why? Because they designed the operating system for PC, human beings. Then there is a one guy, his name is Solomon Hykes. This guy, Solomon Hykes. This guy came and said, okay, no problem. If you are not doing this one, okay, no problem. If you will not allow, okay, no problem. I will write a wrapper on top of operating system. I will write a wrapper top of operating system. You will not do that, no problem. I will take all the resources which is in the kernel directly and I will initiate a user. Think about it. This wrapper, this platform, they have someone has written and they say, I will.
Rajesh, your voice is coming from far and your echo or something.
Oh, is it?
On Yeah, now it's okay.
Okay, maybe that my mic wire is here and there, so maybe that is a causing problem. Is it okay now?
Now it's okay.
Yeah. So guys, this guy said, Solomon Hike said, no problem, you will not do that. No problem. I will write a wrapper, I will write a tool which can directly talk to the kernel. I will not disturb you. I will not disturb you. I will directly talk to the kernel, take all the resources. Which resources I have explained it to you guys? These namespaces. Okay. So I'll take all these resources, libraries, and I will initialize one user. It's all about initialization. I will initialize one more user. I will initialize one more user. And I will initialize each user. I will give mount network PID, mount network PID, mount network PID. So what is container now? Guys, this is your container. The one which is created by Docker is called container. Container is nothing but like us only. Container also get initialized user space. Container get mount also. They get the network also. Get the PID also. They are like us only. But there is a difference. See, let's assume you all logged into my laptop. You know what? You are also container. Think about it in a definition way. But there is a problem with you guys. You all will get only one network, only one mount, and only one PID table. Whereas this user will have their own mount, dedicated mount, their own network, and their own PID table. And because of that, they work in isolation, standalone, without any external dependencies, runtime environment. So now, did you understand what is a container? So guys, let me define here. Understand that container is a user namespace. Each container is a user namespace with one network namespace, one PID namespace, one MNT namespace. Simple. Now, this is created by Docker, not by operating system. I told you Docker, this is Docker. This is Docker. That's the reason I said, what is Docker? Please manage your container, these containers. This create what? Docker doing what? Create one user namespace and assign one network, one PID, one MNT, taking from the kernel. You see, this is the kernel. Did you understand that, guys? Did you understand that now? Guys,
Rajesh, can you repeat that Docker part, if possible?
So this is Docker, guys. This is a Docker, is a platform. What this Docker is doing, Docker is taking all the capabilities from the kernel directly, not interrupting your operating system, and then create one user space and filled with their own network, PID, and MNT without disturbing your operating system. And inside that, you have their own application front. Okay. Now, one more thing I would like to add here. MNT here means, one MNT means, like, again, I'm recalling, understand that. When I say MNT means, understand that. MNT means it's a boot file system, root file system, user file system, application file system. This is your overall operating system, but here MNT namespace is only happen with root file system, user file system, and application file system, not a boot file system. Why? Because see here, where is a boot file system? I said in my notepad, boot file system means kernel. Where is this kernel? Here. So that means MNT means mount, means the user get mounted with the root file system. In a short, think about it. When I log in, think about it. When you log in, you see what? Understand this, guys. When I log into my laptop, I see my desktop. That is a part of user file system. But when you log into container, think about it. What you will see? When you log into the container, what you will see? Guys, any answer? When you log in container, what you would see? Hello? Yes, correct. When you log into container, guys, in short, you will see root, OPT, etc, sbin, bin, or C drive, D drive. Why? Because each container gets mounted with the file system which has, understand that? Each container mounted with a file system which has a root file system, user file system, application file system, but not boot file system, which is kernel. That means container is not an operating system. Understand that. Container is not operating system. So in a short, understand that, guys, here. So container see what was the questions I asked. What are the components needed in a computer to run application? You need a user, you need a network, you need a MNT, you need a PID. And you get it, this one. You need a network, PID, MNT, user, you get everything. And root file system, user file system, application file system, all these things you get it. And then you need a CPU from the C group, which is a kernel. C groups from here and capabilities here. This user will get CPU from C groups. Capability, this user is non-root user or root user, you get it from the capabilities. Everything will get it from the capabilities, the kernel, and this user will be called kernel. That means you will be called as a user, but this special user is being called as a container. There is no difference. See, between you and container, there is no difference except one. You are unfortunate that you are getting the shared network, shared PID, and shared mount, whereas these users are fortunate to have their independent runtime environment. Runtime environment means everything they are getting their own. So guys, in a functional definition, when you go and read what is a container, so container is a independent runtime application environment. Independent means independent runtime application environment without any dependencies outside. That means this is a complete independent runtime. Why? Because you have everything, right? You have everything. You get a PID also, you get a network also, you get a user space also, you get all these things, everything you get it. And you think what is the benefit for this changing the architecture? So guys, the benefit is you are having only one operating system. You are running this container, this container, this container. Cheaper, faster. Cheaper means this Docker, if you compare with hypervisor means virtual VM and VMware, this Docker is consuming very less CPU, RAM, and storage. Here, this container, we have no operating system, so no CPU wastage, no RAM wastage, no storage wastage, no licensing cost wastage. That means in order to run 3 containers, you need one operating system. In order to run 30 containers, you need one operating system only. And Docker is free and lightweight. So guys, did you understand now what each container? Everyone, can you please say in the chat box, what is a container?
Hey Rajesh.
Yeah.
I have a doubt. So Rajesh, suppose I'm running some 4 to 5 containers, okay, with the same proprietary software with the licensing, okay. So I'll be providing the license key and I'll be uploading it into. I'll be creating an image out of it. So and I'm running it in 5 different containers, okay. Do we need to update any licensing, or same kind license can be shared among all the?
Sir, licensing, there are different ways to implement. Some licensing are text-based licensing. Some licensing are from the cloud. Some licensing from the server, license server. So again, all these, these are the application runtime environment. No matter which kind of licensing you use it, ultimately these is a runtime environment. That applications either will access that some of the static file which is located in the image itself or over the network. So behavior will remain same.
Sorry, my question is not about how to implement. My question is about what is the difference. Suppose if I'm running 5 containers, I need to purchase 5 different licenses. Okay. Also, if I need to, the same thing with the VMware aspect. So I'll be running 5 OS and I'll be having 5 licenses for different OSs, right? So what is the main difference between containerization and virtualization in terms of license?
No difference, sir. You are running 5 container or 5 VMs. Both are same in terms of number of licenses. No difference. But the only difference is
we don't have any the vestige is still there, right? Licensing vestige is still there.
Which licensing vestige?
Whatever it is. Suppose I am purchasing a license for 1 container. Okay. So suppose if I'm not using it, there will be a vestige, right?
I'll tell you in this way. First thing, container or VM or of physical machine is the runtime environment. It has no relationship with the application license. Now, when I say container, when we are learning container, actually we are only solving one problem: how to run your application cheaper, faster, and better. When I say cheaper, means your application which you are running in the VM consume lots of CPU, lots of RAM, lots of storage, and operating system licensing cost. I am not talking about your application licensing. It's a different topic altogether. Okay.
I got it.
Yeah, if you look at this here, VMs, here you have get a license, VM license. VM has operating system. But if you look at the container, here you have only one operating system and running multiple containers.
Okay.
Okay.
Yeah, I got it.
So now inside a container, you run, let's say you run Jira. Okay, and Jira you running four containers. That means you need a 4 license. Now, if you running that same Jira in the VMs, you need a 4 license. Or if you run the same Jira in the physical machine also, you need a 4 license. So that's a different topic altogether.
Okay. So when you say operating system license, suppose if I'm install Windows operating system in all the containers, okay, whatever I have. So for that also I need to purchase the license, right?
When you purchase a license, purchasing a license, let's say you purchase 1 license. Now, whether you use in the laptop or VM or container, all are runtime environment, so you can use it anywhere. There's no problem in it. Ultimately, the license would be valid.
Yeah, license would be valid. Suppose if I'm going to use the same license in all some different containers, same operating system. Do I need to purchase the same different license, or I can use the same license for the different?
That's what I said. There's a different kind of licensing is there. That's what I said. This again depends on the licensing provider, tool provider. Because if I say, for example, I'll tell you in this way. I use Jira and I get a license from that license. They have a different kind of license: 1 node license, multi-node license. If I buy a 1 node license, I will use it either in a container or a VM or a laptop. It'll be gone. But if you have a floating license, a different kind of licensing stuff, so depends on those stuff. In a short way, if I tell you, 1 license is equal to container or VM or laptop. Simple.
Okay.
Got it?
Yeah, I got it.
Okay,
Rajesh, one question. For clarification, I just want to clarify. I'm not sure if you have time or do you want to take later.
No. Please tell me questions now.
Okay, fine. So my question is, Rajesh, is like on the taking the example of load balancer that you have created for let's say virtual machine, and based on that we justified the container approach, right?
Right.
So going with that approach, let's say I have one container user group, user namespace that you created, right? Which is like, let's say, having Apache, and second also having user namespace Apache. But network capability or the RAM capability, CPU capability of the underlying hardware or the kernel OS remains the same. Let's say 16 GB, as you said, right?
Yeah.
Taking just memory into RAM into consideration.
Right.
So when we're containing, let's say, user namespace 1, so will it be having, let's say, take example of, let's say, three, four, each will have four kind of GB RAM, or when we will need to scale, the load balancer will kind of replicate and create another container for another 4 GB, or how it will work? If you want to discuss that later, maybe later part of the course.
No.
Just want
It's a very good question. I must address now itself because it's a part of the understanding of the container. Think about it. I'll redraw the picture one more time. Look at this. This is your hardware layer. Now this is, I'm not saying operating system is a kernel. Okay, kernel, you have a network, PID, okay, MNT, and what is that last? User namespace, C groups, capabilities. All this you have understood. Now through this, operating system like will create one user. This is the share. Here. Now you create one operating system will initialize one network, one PID, and one MNT. Now this user will access same thing, all three, and this user also access. These are normal user like you and me. Now what is happening? There is a Docker is creating. Remember where is being placed Docker? On top of kernel. And Docker is also taking the capabilities from here, and creating user. And in this user is having their own MNT, not shared one. One MNT, one network, one PID. One MNT, one network, one PID. Now you tell me, think about it. Where is the C groups? Here it is. Okay, think about it. Who's allocating the CPU and RAM? From here. At the system level, you have a PID, one PID. So now this tool will be running on this system machine, right? This is a tool. Docker is a tool which is running on the system. Now this is a PID, one PID. Now this user and this user will become a process for the host machine. Understand that? That means in a simple way, if I tell you, this will become one process in the host machine only. This also become a process on the host machine. This also become a process in the host machine. Okay, this also become process. This also become process. This also become a process. Every one will become a process. But if you go inside this user, you will see their own PID table, mount, and network. But if you go inside this user, you will see all these things. Okay, so in a simple way, container is a process for the host table. Now, when it comes to the process, who will manage the CPU allocation, RAM allocation? C group of the kernel. Now, on that basis, whether this user you want to make it free, whatever the CPU and RAM you have available, you can use it. That's a rule. You can make it available, or you can set this user, you are allowed to only use 2 GB or 4 GB or something like that. That can be done. So container is just like a user and in a short way process in the host machine. Okay. Does that answer your question?
Yeah, to an extent. Let me see if something I can come back to you. For now, I'm fine. Yeah. Thanks.
Okay. So guys, let's recap one more time here. If you really want to understand container, you need to get into this question. What are the components needed in a computer to run any software? And we got to know, in order to run any application, you need an operating system, then inside a kernel, then namespaces, and these capabilities and C groups. Now we understand that we are migrating from the desktop to virtual machine, and then from now we are migrating to a container. But the question is remains same. What is a container? Objective is in a data center to run app, but cheaper, faster, and better. So we have migrated to virtual machine to container. In the virtual machine, we had a disadvantage. We had advantage. It was avoiding the wastage of the desktop CPU, RAM, and storage, but it has a one disadvantage. You need a multiple operating system to run multiple applications in a VM, which we can overcome from in terms of containers. How? So we explained it to you some of the stuff which is needed here. So what we did, we started creating a user. Each container is a user namespace with one network, one PID, and one MNT. Where is this MNT? Is nothing but the root file system, user file system, and application file system. Okay. Now who's doing it? Docker. So basically, Docker is a container management tool. It has a different kind of release. One is community edition, and one is enterprise edition. Enterprise edition. And now this is paid. I'm teaching you community edition, free. Okay, this is written in Golang, guys. Written in Golang, and from the Solomon Heights, okay, and so on. Okay, so guys, this is the introduction of Docker and containers. Now, next questions which I'm going to address is other container interface. That's the second question. Docker, how Docker works, aka Docker architecture, Docker workflow, I'm going to teach you. Container lifecycle, I'm going to teach you container lifecycle. And before that, I am going to install Docker installation. Okay, so these are the 5 topics I will cover post lunch, and then we'll have a lab and demo including, and get going. Any questions, guys, before going for the lunch break?
Yeah, Rajesh, sorry, one question, last question. When we said that it is a shared thing, right? It's the process that we have created, right? That Docker is getting a process in the main kernel, right?
Yeah.
And each container itself is a process, right?
Yeah.
So when we say like each container will have a network IP, right? So is the Docker actually acting as a proxy or virtualizing the because to the external world maybe the network is same, right? Is the Docker virtualizing this IPs and all or something like that?
So here I said you as a normal user share the network which is created by operating system at the host level. But these containers get allocated their own network and managed by Docker 0, which is one bridge network, which I'll talk about a little bit later. But in short, if I tell you at the high level now, these containers, these users are having their own network initialized, and they do not share the network from the host machine by default. Though there is a types of the network driver also, but I'm not confusing you too much for time being. These containers will have their own network IP addresses, in short.
Okay. Okay, fine. Fine. Thanks, Rajesh.
By network IP address, do you mean a public IP address or a local 192.168 IP address?
See, this IP address, the scope of the IP address will be limited to the host machine only, not a public IP address. Public IP address is, when we say public IP address, that means accessible around the globe. How a container may have a public IP address? It cannot have that IP address, no? Static IP address is not possible. So yes, they will have an IP address, but scope of the IP address is limited to the host machine only.
Okay.
For example, let me tell you, you are connecting from home through your home network. So you will have an IP address, definitely, but that IP address will be scoped only till the home, in your router only, your Wi-Fi. That IP address will not be accessible outside of your home. So every compute unit get an IP address from the network namespaces, but scope of the network defines where that can be traceable. For example, even though if you have a public IP address, let's say you have a people in planet Mars, they are not connected to us through the wire, so they will not be able to access it like that. Scope of the network has to be there. Make sense?
Yes. Yes.
Okay, guys. So, yep. Any other questions, guys?
If you liked our Docker session so far, please enroll our general membership for $399 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.